Hello folks, this is Tom from anti-proton.com, and yes, this is a, if you can read it here, an Oculus Rift. This is the Mark II development kit, which I just happen to have. I have an interesting little experiment. Maybe it's not like my most interesting experiment ever. I was going to show you it. It's pretty creepy actually. But beforehand I had some announcements. I have not made a video in several months, like 1 or 2 months or something. And for a couple of reasons. Number one reason, I have had a whole bunch of stuff to do at work. Number two reason, I'm finishing up, I shouldn't say I'm finishing up, that's not really true, I've actually already submitted it. I'm publishing my book, and before everybody asks about it, it is not a science book, it's actually a fiction book. You know, whatever. Like I said, I'm not actually a physicist. I know I do physicist things, but I'm not actually one, so I'm not really qualified to write like a physics book, right? I mean, you know, you'd want to, if I wrote a physics book, you'd expect me to at least have, at least like a master's degree in physics, right? You'd think. I mean, otherwise, my stuff could be completely right, but you'd have to go fact check everything, and that's no fun. So I didn't write any sort of book like that, and I could write a computers book, like a programming book or basic computer science book or something, but that's no interest for me either. However, I am getting back into virtual reality. I've been saving money to buy 2 vast computers. One of them so I can use this guy right here. I used to be interested in virtual reality back in the 90s. I did VRML, Virtual Reality Modeling Language, if anybody's ever seen that beforehand. Let me pull this off. I'm sure I have like weird marks all over my face. This thing's kind of cool though, isn't it? Look, see? Neat. The Oculus Rift. I got a hold of one of those. Call me an early adapter, but you know, I love virtual reality stuff. For example, Sword Art Online. When I went to Japan, oops, the sword just popped off. That's alright, I'll put it back on in. I bought all the little figurines and everything to go with Sword Art Online. That's awesome. 2,200 yen. See? And she has like a little sword too. I've got a bunch more of them. Yeah, I have a whole bunch of those figurines. But anyway, so I've always been interested in virtual reality. Oh my god, my hair's probably like all over the freaking place. Now, moving on with my experiment. My first experiment, the one I was going to show everybody, is what actually failed. And one important thing about science, which makes science better than like other methods of trying to derive reality, of which there aren't really any plausible other methods of deriving reality, is that science is falsifiable. That's actually really important. I attempted to do a quantum entanglement experiment involving sodium-22 producing pairs of photons which were quantum entangled, if you like. They had a correlation between their momentums, or at least I believe that they did. That was the experiment to find out if that was actually true or not. And so one photon would go into the detector, and the other photon would slam into a wall, and its momentum would change, and so on. Now, the quantum mechanics required to describe that is actually beyond my personal ability. I mean, it's a significant amount of quantum mechanics right there to describe what's actually one system. But anyway, the results of that were not, they were interesting, and you can kind of, you get like a gut feeling that you see something going on, but a gut feeling is not statistically viable, and I cannot get a statistically viable answer out of the test, so I'm kind of putting that aside for right this moment. I also looked into doing quantum entanglement with lasers, but I need to upgrade some of my equipment before I can do that. My current laser is, if I entangle the photons coming from them, I won't be able to see them. They'll be too low in energy. So I need to work on all that. So just for giggles, as I was sitting here thinking to myself, you know, I haven't produced a video in a while, and I'm going to produce a couple more, but what would be something just kind of fun for giggles? I know. I'll do a gamma spectrum of human urine. Why the hell not, right? You know, it's crazy. It's the kind of thing you put in like a science fair, you know. That, or it shows maybe you're crazy if you have like bottles of your pee sitting around everywhere. But yeah, so over the course of several days, I collected samples and mixed them all up. and I ran a 2-hour background and a 2-hour spectrum of them. Now, I didn't find very much in it, but it was sort of interesting to look at. No, I'm not going to show you the sample container. You're just going to have to take my word for it. Okay, I'm not going to be like some people who do nuclear videos. You know who you are, who actually show yourself boiling like over a stove. Well, that was pretty funny. So let me go and show you that really quickly. And yes, I will be back. I am not gone forever. I got a message this morning suggesting that maybe I had retired. No, but I have had to take some time off, so there you go. Enough of me babbling. On with the show. Alright, so this is the spectrum for a 7,200-second test. That's 2 hours, of course. Background removed. And as you can see, I tested from around 5-6 kilo-electron volts all the way up to 2,373 kilo-electron volts. That's just what I calibrated my detector to. I used a cobalt 60 and a cesium-137 calibration. I usually use both of those two sources. They give me a reasonably decent linear calibration across this. Of course, my calibration is not really linear anyway, but it's approximately linear. All right, I kind of did random checking through these areas, looking for nuclides that I thought might be there and things that I didn't know might be there, and I couldn't find anything here that was enough to show any sort of statistical correlation. I see lots and lots of things here which my gut feeling tells me I think I have some idea what they might be, but there's science and there's a gut feeling. Gut feelings are neat. Science requires actual proof of things, which would be the opposite of gut feelings by definition. So I'll tell you my gut feeling with the quote saying that that isn't actually science. There's probably some uranium going on here. It would make sense because you do take in about 400 micrograms a year according to the IAEA. It's a very, very small amount, so there could be some going on in here. Probably some beta producers. It's quite possible. But nothing that can be proven. I would require something like a high purity germanium detector, and a pretty good one actually to see anything really of any significance in here. I found one thing that stuck out, and I tested for one thing explicitly. So let's go into this. The cesium-137 I tested for using the known region of interest that I got off of the actual calibration sample. And let me show you my method I use. Oops. Method. Okay, method, I've shown this to you guys beforehand. That's the math I use up at the top. It seems a little redundant, but that's because I throw this through my calculator, so that's why some of these steps are sort of a little redundant. I need to put it in the calculator like that to make it work. You can simplify this greatly. But basically put for a area that I'm looking at, I take the two sides, right here, and I project where the background would be if they just remain that way. And if I see anything that's above that, above the projected background, I then use a confidence interval. In this case, I think that's a one-tail 95% confidence interval. I have to go look it up in my list of books. I think, yeah, that's 1.645. Should be 95% one-tail confidence interval. And so everything that's above the confidence interval right here is a statistically valid detection. So basically I'm just calculating a critical limit and then taking everything above it. I'm not calculating activity or anything like that from there. And I didn't take into account like an upper limit, for example. This is not a scientific research paper. This is more just for fun and interest. In this area right here, I got a score of negative 308.807 counts. So that means very, 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 very much not a detection. In fact, quite a confident negative detection, if you like, meaning nothing there, which I didn't expect there would be. I just did that because everybody always asks, what about cesium-137? As for potassium 40, that's what I found over here at 1461 keV. This is probably from all the potassium-containing foods that I eat, bananas, potatoes, all those sorts of things. Your body keeps exactly as much potassium as it needs and ejects the rest of it, and of course the pee is a great way to get rid of it. Potassium 40 is one of the 3 isotopes of potassium that you usually ingest. It's just a tiniest little bit that you take in, but it is radioactive, and it undergoes all 3 beta standard types of beta decay, so beta positive, beta negative, electron capture. Electron capture is not really it's, I shouldn't call that beta exactly, but it's in a little thing. So it goes through all of these interesting forms of decays, emitting, yes, positron radiation, all kinds of neat stuff. And so I did find this. The detected count, statistically verifiable ones, were 102.157, so that's a reasonably confident detection. You can even see it as looking at it, but like I said before, just looking at stuff's not good enough to validate anything. Here's what potassium can look like. That's a nice photo peek of potassium, by the way. I took a whole bunch of potassium chloride salt and stuck it in front of my detector to get an idea of what that looked like. So give you kind of an idea. That's the Compton edge right there. So nothing interesting too much, just me taking a gamma spectrum of my pee. And I'm going to leave you now with some of my quantum entanglement video, 3D video stuff that I never used because the experiment was a bust. If I can make the experiment work, if I can figure out where I went wrong, I will use the video, but if I don't, I'll just leave it with you because it was time-consuming to make. I'll just zip through it. So this is Tom from anti-proton.com. Sorry the video is not the most amazing thing on the earth, but I have better stuff coming. Bye-bye.